Imagine standing on Mars for the first time. The ground under your boots is red dust. The sky above you is thin and silent. In every direction, there is a whole new world. But then you remember the most important thing. There is no oxygen. Not a little oxygen. Not air that is hard to breathe. No breathable oxygen at all. You cannot remove your helmet. You cannot open a window. You cannot take even one normal breath. So, if humans ever build a civilization on Mars, where will the air come from? On Earth, air is so normal that we almost never think about it. It is just there, around every building, inside every room, moving through every forest, street, farm, and city. Nobody wakes up and wonders if the atmosphere will still be there tomorrow. But on Mars, air is not background. Air becomes a problem, a resource, a technology. Something that has to be created before almost anything else can happen. Because before humans can build schools, roads, hospitals, factories, farms, or cities on Mars, they have to solve something much more basic. They have to create the conditions that Earth gives us for free. Air, pressure, protection. A place where the human body can simply continue existing. And that is where the real problem begins. Mars is not just far away. It is not just cold. It is not just dusty. Mars has an atmosphere, but it is extremely thin compared to Earth's. And most of that atmosphere is carbon dioxide. For humans, that is useless as air. You can stand in the middle of a Martian landscape and be surrounded by gas, but still have nothing you can breathe. That is the strange part. Mars has a sky. Mars has weather. Mars has winds. Mars has dust storms, but it does not have breathable air. A desert on Earth can kill you with heat. A mountain can kill you with cold. The ocean can drown you, but at least those places still have oxygen. Mars removes even that. So the first question is not how humans will make Mars comfortable. It is how they will make it survivable. At the beginning, some oxygen would probably come from Earth. Early missions could bring tanks, backup supplies, and emergency systems. That makes sense for explorers, but it does not work for a civilization. If every breath depends on rockets from Earth, then Mars is not independent. It is a campsite waiting for deliveries. A real civilization cannot wait for every tank of air to arrive from another planet. It needs local oxygen, it needs to make air from Mars itself, and Mars does have the ingredients. They are just locked inside things humans cannot breathe. The first major source is the Martian atmosphere. Mars air is mostly carbon dioxide. Humans cannot breathe carbon dioxide, but carbon dioxide contains oxygen atoms. The challenge is separating them. That is why NASA sent a small experiment called MOXIE on the Perseverance rover. MOXIE was not a city-sized oxygen factory. It was not built to keep astronauts alive. It was a small test. A machine trying to answer one huge question. Can we take the air of Mars and pull oxygen out of it? And the answer was yes. MOXIE produced oxygen on Mars multiple times. By the end of its mission, it had made about 122 grams of oxygen. That is not much. It is not enough for a city. It is not even close. NASA compared it to roughly the amount of oxygen a small dog would breathe in 10 hours. But the amount was not the important part. The proof was. For the first time, a machine on Mars made oxygen from the Martian atmosphere. That changes the idea of settlement. Because humans would not only bring oxygen, they could bring machines that make oxygen after they arrive. But making oxygen for a small test is one thing. Making oxygen for a civilization is something else. A Mars settlement would need industrial oxygen systems, not one little box. Many machines, some producing oxygen for people, some filling emergency tanks, some storing reserves, some making oxygen for rockets. Because on Mars, oxygen is not just air. It is also part of the way home. Rockets do not only need fuel, they also need an oxidizer. On Earth, rockets carry liquid oxygen because space has no air to burn fuel with. A rocket launching from Mars would also need oxygen. And bringing all of that oxygen from Earth would be extremely difficult. So future Mars missions may need to produce oxygen locally, not just for breathing, but for return flights. This makes the oxygen problem much bigger. A person needs oxygen slowly, breath by breath. A rocket needs oxygen in huge amounts all at once. A real Mars civilization would need both. The second major source is water ice. Mars has water ice in the ground and near the poles. Water is made of hydrogen and oxygen. If humans can mine ice, melt it, clean it, and split it using electricity, they can produce oxygen. That process is called electrolysis. On paper, it sounds simple. Water goes in, electricity is applied, hydrogen and oxygen come out. But on Mars, every step is difficult. You have to find the ice. Dig it out of frozen soil. Protect the equipment from dust and cold. Remove impurities. Store the water. run the electrolysis system, compress the oxygen, move it safely, and keep the whole chain working for years. A broken pipe on Earth is annoying. A broken oxygen system on Mars could become an emergency. This is where Elon Musk and SpaceX enter the story. Musk does not talk about Mars as just a short scientific visit. He talks about a self-sustaining city, a place where humans could live permanently, not just land, take samples, and leave. SpaceX's plan is built around Starship, a giant reusable spacecraft designed to carry large amounts of cargo and eventually people. But rockets alone do not create a civilization. Starship could bring habitats, machines, solar panels, reactors, drills, tanks, robots, greenhouses, spare parts, and people. It could bring the beginning, but after that, Mars has to start producing air, water, fuel, food, materials, repairs. If a Mars city depends forever on Earth, it is not really a city yet. It is an outpost. SpaceX has described the long-term goal as a self-sustaining settlement, possibly requiring huge amounts of cargo and eventually very large numbers of people. That sounds extreme, but the reason is simple. A civilization is not just humans standing on a planet. A civilization is systems, food systems, energy systems, repair systems, transport systems, medical systems, construction systems, and on Mars, the air system becomes the heart of all of them. If the air system fails, nothing else matters. This is why the first Mars city would not look like the cities we know. It would not begin with open streets, parks, and people walking under the sky. It would begin as a life support network, a sealed world. Walls would not just divide rooms. They would hold pressure. Doors would not just open. They would become airlocks. Windows would not just let in light. They would be barriers between life and death. Habitats would need oxygen sensors, carbon dioxide scrubbers, pressure controls, leak detectors, pumps, filters, emergency tanks, and backup systems. The first Mars city would not breathe like Earth. It would breathe through machines, and those machines would need power. Oxygen is not free. Moxie needed electricity. Electrolysis needs electricity. Heating ice needs electricity. Pumps, filters, compressors, greenhouses, lights, computers, robots, and emergency systems all need electricity. So building air on Mars also means building energy. Solar panels might help, but Mars is farther from the sun than Earth. Dust can cover panels. Dust storms can darken the sky. For a permanent settlement, nuclear power may be important because it can work when sunlight is weak or blocked. Most likely Mars would need several energy sources and many backups, because on Mars, redundancy is survival. One oxygen machine is not enough. One power source is not enough. One greenhouse is not enough. A civilization needs layers, main systems, backup systems, emergency systems, stored oxygen, spare parts, repair crews, robots, and enough time to fix problems before they become disasters. But oxygen alone is still not the whole answer. Humans do not simply live in pure oxygen under normal conditions. Breathable air also needs pressure. It needs the right gas mix. It needs humidity. It needs temperature control. It needs carbon dioxide removal. Too little oxygen is dangerous. Too much oxygen can increase fire risk. Too much carbon dioxide can poison people slowly. Too little pressure can damage the body. So a Mars city does not just need oxygen. It needs an artificial atmosphere. Every habitat would be like a tiny version of Earth's air system, trapped inside walls. And the larger the settlement becomes, the harder this gets. A small crew can be monitored closely. A city is different. People would sleep, cook, exercise, work, grow food, repair machines, use oxygen, exhale carbon dioxide, create waste, open doors, move between modules. Every part of daily life would affect the air. That means air on Mars would be managed like electricity, water, and food, measured constantly, recycled constantly, protected constantly. Even farming would depend on this system. Plants can help produce oxygen, but they are not magic. A greenhouse on Mars would still need pressure, warmth, water, nutrients, lighting, and radiation protection. You cannot just throw seeds into Martian soil and wait for a forest. Early food would probably grow in sealed greenhouses, hydroponic systems, or controlled indoor farms. Water would be recycled. Nutrients would be managed. Light might come from LEDs, and plants would be part of the life support system, not just decoration. On Earth, a farm is land. On Mars, a farm is machinery with leaves. So a green Mars city would not begin with open fields. It would begin with sealed rooms where every plant is an engineering project. This is the slow path from base to civilization. First, humans arrive with supplies, then machines make small amounts of oxygen, then the machines get larger, then ice mining begins, then oxygen storage grows, then fuel production becomes possible, then greenhouses expand, then repair shops appear, then habitats connect, then the settlement survives longer without help. At some point, if it can make enough air, water, food, power, and fuel locally, it stops being only a mission. It becomes a society. A Mars base becomes a civilization when it can survive a missed supply ship. That may be the real test. Not whether humans can plant a flag, not whether they can stay for a few weeks, not whether a rocket can land, but whether people can keep breathing when Earth is far away, and the next delivery does not arrive. But then comes the biggest version of the question. Could we change the whole atmosphere of Mars? Not just make oxygen inside habitats, not just fill tanks, but turn Mars itself into a planet where humans could one day walk outside and breathe under the open sky? This idea is called terraforming. In science fiction, it sounds simple. Warm the planet, thicken the atmosphere, release trapped carbon dioxide, maybe add greenhouse gases, let ice melt, let plants or microbes spread, and over a long time, Mars slowly becomes more like Earth. But real Mars is much harder. To live outside without a suit, humans would need two things: enough atmospheric pressure for the body to survive, and enough oxygen in that atmosphere to breathe. Mars has neither. Its atmosphere is less than 1% of Earth's pressure, and it is mostly carbon dioxide. So the first step would not even be oxygen. The first step would be pressure. You would have to make the atmosphere much thicker before open-air life could even be possible. Some ideas suggest releasing carbon dioxide from the polar caps, soil, and minerals to warm Mars and thicken its air. But studies have found a major problem. Mars does not appear to have enough accessible carbon dioxide to create an Earth-like atmosphere with present-day technology. Even if the easily available carbon dioxide were released, the pressure would still be far too low for humans to walk outside without protection. So could we make Mars produce oxygen like Earth? Maybe in theory, but not in the simple way people imagine. Earth's oxygen was not created overnight. It was built over billions of years by life, especially photosynthetic microbes and plants. Mars does not have oceans full of life. It does not have forests. It does not have soil ecosystems like Earth. It does not have a thick protective atmosphere. If we placed plants on the Martian surface today, they would not simply spread and turn the sky blue. They would face cold, dryness, radiation, low pressure, toxic soil chemistry, and no breathable atmosphere. So the first oxygen on Mars will probably not come from forests. It will come from machines. Maybe one day engineered microbes or biological systems could help produce oxygen inside controlled habitats. Maybe far in the future, humans could build planetary-scale systems that slowly change parts of Mars. But turning the entire Martian atmosphere into something humans can breathe would be far beyond the first settlements. Even if future technology could thicken and warm Mars, there would still be another problem: keeping the atmosphere. Mars is smaller than Earth, and it does not have a global magnetic field like Earth's. Over time, the solar wind helped strip away much of Mars's ancient atmosphere. That does not mean a new atmosphere would disappear instantly, but it does mean maintaining an Earth-like Mars would not be easy. It might require constant engineering for thousands of years. So the honest answer is this: in the near future, humans will not live on Mars by changing the whole planet. They will live by creating small artificial Earths inside sealed spaces: domes, tunnels, habitats, greenhouses, underground cities. The dream of open-air Mars may belong to the far future, but the first civilization on Mars would almost certainly begin behind walls. Their civilization would not begin by making Mars Earth-like. It would begin by making small pieces of Mars survivable. And that is the answer. If Mars has no oxygen, humans will not build civilization by breathing Mars. They will build civilization by manufacturing air. They will extract oxygen from carbon dioxide. They will split it from water. They will store it in tanks. They will pump it through habitats. They will recycle it from breath and plants. They will protect it with walls, machines, sensors, and backup systems. The first Mars civilization would be a place where air is not nature. Air is industry. Air is engineering. Air is survival. And eventually, air becomes the foundation of society itself. So if humans ever build a city on Mars, the first miracle will not be the buildings. It will not be the roads. It will not even be the rockets. It will be the fact that inside a dead, red, silent planet, someone takes a breath. But maybe that first breath will also remind them of something. How strange Earth really was. A planet where air touched your skin without a machine, where you could open a window without dying, where forests made oxygen without anyone pressing a button, where rain, Wind, clouds, oceans, and trees worked together quietly in the background. On Mars, every breath will have to be made. And maybe that is when humans will finally understand Earth, not just as a home, but as the life support system we never had to notice.